Hello everyone, welcome to the channel and welcome to this video. Here I'm going to discuss the various problems that came up in Codeforces round 927. I'll be covering the 5 hard problems, leaving out the first 2 easy problems. So starting with my introduction, I am a software engineer 3 at Google. I've been a competitive programmer. These are a few of my records. I've been to the ACM-ICPC Regionals, in Facebook Meta Hacker Cup, also in some other contests like Expedia, Hack with Infi, and some other popular ones. I've been a master at Codeforces, 6-star at Codechef. I'm a BTech honors in CSE at IIT Bhilai. I've graduated there. And I've done some research work as well in fields like blockchain and edge computing. I have some publications and I've been a former member of National Blockchain Project at IIT Kanpur. So yeah, in this particular video, I'm going to discuss the various problems, the last 5 problems of this Codeforces contest 927. And apart from the kind of editorials that I've been working on in the last few videos that you might have seen, over here, I'm going to focus on this special person, Gennady Korotkevich, whom sort of we all have kind of followed or in a way worshipped over the last so many years. You can see this guy started coding at somewhere around 2010, if I'm not wrong, and now this is 2024. This actually tells something about this guy. You can actually see how active he has been through the years, and he has been at this legendary grandmaster for such a long time. We have so many other great programmers, awesome programmers who have actually entered this red range or actually been to this yellow and then the red range, and they have perhaps dropped down, again climbed up, dropped down. They have shown different patterns. But when you see these graphs, it actually tells you something about their stories, how these people are different. 12 years, I think, or 14 years, it's close to 14 years. He is a legendary grandmaster. Definitely, he doesn't need my introduction. A very popular personality of the competitive programming community, competitive programming world. But a little bit, 3979 has been his maximum rating. Um, I think so far as I have known him, he has been coding in C++. And even if you see this year, you can see such an interesting deal of participation. And I'm pretty sure most of you will know that he has also been active in other platforms as well, not just Codeforces. So anyway, what I'm basically going to do is in this contest, in this discussion, I'm going to look at few problems, and just like previous videos, I'm going to share ideas on how probably it can be solved, and then we will look at how Tourist has solved it. We'll try to gain some insights on how Tourist has taken some fine steps, or where Tourist has done some interesting steps, where he has done things a bit differently, where things could be done a bit differently, and Tourist has chosen one of them. We'll see those, a few, will try to see some of those, but one very important disclaimer. This session, or my objective in this session, is never to sort of give you a false guarantee that through these sessions you are going to become like Tourist, or these sessions are really sufficient to be so, to actually even try to be close to be so. We'll try to gain some insights, which may be a very small percentage of that entire thing, but we'll try to see the small things he has done, and that will not tell us everything about what this guy is. That will not tell us everything about his capabilities, etc. That will be a very small percentage, but that still probably, in my opinion, in my understanding, will be a source of learning for us. So let us see some of the things, some of his solutions through these Codeforces problems. Okay, starting with the first problem that we are going to see today, it's LR remainders. The problem basically says that, hey, you're given an array of length n, a positive integer m, and a string of commands of length n. So what you're supposed to do is, in every step, you will output the remainder of the product of all the elements of the array. That is, whatever elements are there, you're going to take the product, and then you will divide by m, and whatever remainder will be there, you will output that. And after that, you will, if the command is L, you will remove the leftmost element, else you will remove the rightmost element. Right. Note that after each move, the length of the array decreases by 1. So what are we doing? At every step, we are first outputting the remainder, and then we are removing one element. We will do this n times, so at the end we will remain with an empty array. Now write a program that will process all commands in the order that they are written in the string S, from left to right. So let us take some example. Let's say it's this one. Let's say 1 2 3 4 5 6. So let us try to understand. This is our array. 1 2 3 4 5 6, and next I'm trying to see, okay, this is R L L L R R R L L L R R. So first of all, before you remove anything, what is the sum? What is the product? The product is 720. Okay, and now we need to see the value of m as well. M can go up to 10 to the power 4, and over here m is 8. M is 8. So m equal to 8. So 720 modulo 8 gives us 0. That is the first thing I think you should print. Yeah, it is 0 over here. Next we will basically read this. Okay, this is R, so we will remove the rightmost element. So what we stay back with is this much: 1 2 3 4 5, and now we will do the same thing. It's 120 modulus 8. This also I think is 0. Okay, next I will do this. I'll say L, so I'll remove the leftmost element 1. The remaining thing remains 2 3 4 5, and we will say, okay, it's 120 once again modulus 8, which is again 0. So this is the order in which we'll be printing 0 0 0. Next we will say, okay, remove the leftmost element removed, so now it is 3 4 5. 3 4 5 will leave us with 60, if I'm not wrong. 60 modulus 8. 12 5 is 60, yeah. 60 modulus 8 basically will leave us with 4. So my next value to be printed is 4. Then what will I do? I'll say, okay, now remove the left element once again. So you stay back with 4 5, and 4 5 will give you 20. 20 modulus 8 is equal to 4. Next we will say, okay, next is R, so remove the right one. This leaves you with 4. So 4 modulus 8 is also 4. And next one, whatever it is, doesn't matter. It is R, so we will take 4. Okay, I think when we are processing this R, that is the time when we will calculate this, and then we will remove this. Yeah, this is the steps. These are the steps. So essentially we have to compute this and we have to print in this order. Now, what is the brute force over here? I skipped the first two questions because those will probably use brute force. So you can just apply brute force. If you have any doubts, you can ask me. Coming back over here, if this is a brute force kind of, if the constraints allow brute force, will it allow? N goes to 10 to the power 5. So if the brute force is only about n or n log n, then we can use it. What is the brute force here? Simulate the operations. So remove the rightmost or leftmost element and then focus on the remaining part, take the product and do it. Otherwise, okay, so if I do that thing, that okay, remove some part and then take the product of this part, then remove maybe the left thing and then take the product of this part. If I do these kind of steps, can I say the first step I'll be taking the product of n integers, then I'll take the product of n minus 1 integers, then n minus 2 integers, and product of these integers will basically be big O of n. So n minus 2 multiplication of n minus 2 numbers is going to take n minus 2 steps, something like that. So basically n steps here, n minus 1 steps here, n minus 2 steps here, and so on. When I add them up, it will be big O n square. And I know if n is basically going towards 10 to the power 5, this algorithm or this time complexity is not suitable for me. So now how to optimize it? The first thing, honestly, the first thing that came to my mind is that, okay, it's basically a product from where now you have to divide few things. It's something like if you have 720, then by dividing this 6 and this 1, you can basically get it. You can get these numbers. By dividing this, you can get these numbers. So what was the first thing that came to my mind is, okay, if the initial number is not so big, I can apply that strategy that, okay, divide by 6, then divide by 1, then divide by 2, and so on. You keep on getting the next product so easily. But the topmost product, what can it be? In the worst case, it will be 10 to the power 5 factorial. 10 to the power 5 factorial, which is a huge number. This is a huge number. And theoretically, it is possible for your Python or even your Java, big integer, all those tools to actually reach you up to some place. But if you're basically multiplying these numbers, if you're working with such huge numbers, somewhere your Python or whatever these tools are, there will be some huge time consumption. So you can actually try to see with these languages or these tools. But I think even if it is allowed by the language, the time complexity will somehow become a hindrance because you're multiplying such huge numbers. You can imagine. So if I take up to 10 to the power 5 minus 1, or 10 to the power 5 minus 2, something like that, that itself will be of 10 to the power 5 into 4. That itself be of this many digits. The answer will somewhere reach up to these many digits. 4 lakh or zero point 0.4 million basically. 400,000 digits. That's a huge thing. If you're dealing with such a number and you're multiplying that with another number, it's really a costly operation. So anyway, this was an approximation. So with huge numbers, definitely don't think. Next thing that came to my mind, okay, modular inverses. That if I know x modulo m, can I know x divided by a modulo m? Given that x is divisible by a. Well, this is sometimes written as this x into a inverse modulo m. And a inverse modulo m, if I can name this as b, we basically say that a inverse is such a number that a into b modulo m is equal to 1. And that is only possible if GCD of b and m, sorry, the GCD of a and m is equal to 1. So in short, you can do that operation. You can actually find a modular inverse and you can go along the path of modular inverses. But for finding the modular inverse, you actually need this condition to hold, that the GCD of a and m, what is a and what is m? If I'm wanting to divide by a and if I basically want modulus by m, then these two numbers should be coprime. Who gives that guarantee? In this given problem, do I have that guarantee? In other problems, usually we get such option because usually the m is a very large prime number. In many, you might have seen in many other problems, we get 10 to the power 9 plus 7 or such huge prime numbers. So there it is possible. There it is basically possible. But over here, definitely m is given that it can be any number from 1 to 10 to the power 4. No condition mentioned. So definitely then it is not going to hold. If m can be anything, then we cannot use this particular strategy. And then what can we use? Now, we can say that, hey, if you allow me to solve this first, and then this one, then this one, then this one, and so on, from bottom to the top, can I say it is pretty easier? Why? This is pretty easy, one step. Then over here, for this, I just need to multiply by 5. I just need to multiply by 5 over here. Next step, just multiply by 3. Next step, just multiply by 2. Next step, just multiply by 1. And next step, just multiply by 6. That's it. So if I proceed from bottom to top, if I say, okay, first I'll calculate the bottom and then the top, then we are fine. Then we can calculate all of them and then I can print in this order. That's totally fine. Now, in which case would it not be possible? If the program would have basically given me online queries. What are online queries? Let's quickly discuss that. So if let's say we are given R, and with R we have to print an answer. So let's say we have to print 0. Then for L I have to print next answer 0. Then I will get L and then I have to print 0. I won't get all of them, let's say, at the beginning. Let's say I won't get all of them. I'll get the queries one by one, the commands right and left one by one. Then I cannot say that, okay, I will collect all the commands based on them. I will figure out that at the end which element will be left, then which elements will be left, and so on. If I know what are my right left sequence, what is my right left sequence, then I get this sequence completely. I know that which is the last element to exist. How? Because I can say, okay, my L, my left are basically 3 in number, my right are basically 3 in number. So 3 removals will happen from the left, 3 removals will happen from the right. I can say whatever is the count of L, that many removals will happen from the end, that many removals will happen from the right. And then I can say, okay, from the end, basically the last removal is towards the right. So somewhere I can say that this is basically removed by that last command. So before its removal, I'll have the answer 4. Then I'll say, okay, then the next one is R. The second last, that is R. So the next one R will go to is this 5. So I'll say, okay, current answer into 5. Current answer into uh, 5 will basically give me 20. And so on. Then I will see, okay, L. So I will say, okay, forget R now. Now L. L will start over here. So from the top, L basically goes first into this, then into this, then into this. But since I'm going from the last, I will say, okay, L first from the last, L basically touches 3. So this L is going to touch this 3. So if I form that kind of a pattern, I will say that this R will take care of the first right, this R will take care of the second for the right, this L, I'll do in a different color, this L will basically take the responsibility of this 3, then the next L a step more to the left, the next L a step more to the left. So this is the first L, from the left there is the first L, and then again the right will say, yes, I am in charge of the rightmost string. So that is how it is doing. So if you figure out that, okay, this is where my left L will move to the left and R will move to the right, you can gradually get this. You can get this 3, 2, 1, 4, 5, 6 in that order. So yeah, and why is that possible? Because we know how many R and how many L are going to be there. So at the end, what is the command and from where that will take the element? We know that. We know that this R is going to map to this 4 because we know that there are 3 L's. So those L's will basically take care of the first 3 elements. So this last R will basically take care of the 4th element. This is the kind of thing I know. And why is this possible? Because these are all online queries. Online queries means I have the privilege of sorting or changing the order of my operations. I can say what I had to do at the very beginning, I'll choose at the very end. I'll do at the very end. So I'm reversing my flow. I'm basically saying I'm going to go from bottom to the top, and I'll print. While printing, I'll do it in the opposite way. That's it. And what do we know? Do we have to store everything? Do we have to store the entire products? No. Keep on using modulus m, because I think it's De Morgan's law or something like that, that a into b modulus m modulus m is equal to a modulus m into b whole modulus m. I mean, b also you can write b modulus m. But what I'm basically trying to say is, if you don't store a, if you store only a modulus m, that is also sufficient for basically evolving your solutions, for taking your solutions. That's it. So now we will look at the solutions. You can see very quickly over here, let's see. In the first 3 minutes, the first 2 solutions were done. So if you try to see over here, this happened probably, this was the first, this was the first question is solved. And then before waiting for the verdict, he moved to the second question, he solved it, and then again came back and solved it correctly. So there was something, we are not going into that. Now, focusing over here, he basically took 2 minutes, around 2 minutes to solve C. We discussed for around 20 minutes, And these were all the possibilities we discussed. This guy took around 2 minutes to solve this. Then 5 minutes over here, then 2 minutes over here, then 7 minutes over here, and then 9 minutes over here. Again, this is an approximation. I'm just trying to share some estimates of what are the things he has done, how he has done, etc. Never will it be 100% accurate because tourist is much above the things that we are discussing. He is basically over here. I'm trying to just get some good things out of what we can see through some naive eyes, through some naive vision on his page. Okay, so let us look at his solution, the solution to C. Now, this is the first interesting thing in the solution of tourist. It's a simple C++ code. If you look at solutions of many great computer programmers, you will find really involved templates. Many of us actually use our own templates so that we don't get distracted. We don't have to think about how to solve those smaller problems. This guy actually starts most of the things from scratch. He does most of the things from scratch. And that actually tells volumes of how he has practiced, how much he has things at his fingertips, and many more things. So let us see how he has solved it. He has taken elements as input, and then this is the string of commands, and then he is saying r equal to l. So he's basically okay, let's see over here. He has basically counted how many l's are there in the string. He had taken the string over here, and now he is counting how many l's are there in the string, right? This gives us the number of l's, and now r equal to l. In terms of index, what can we say? He is saying r equal to l, which is equal to the number of l's in the command. Yeah. So if I try to see over here, what is he doing? He is saying that, okay, these are the indices 0, 1, 2, 3, 4, 5. He is saying L equal to 3, the number of L's, because it's basically R, L, 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 R, R, L, 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 R, R. So the number of L's basically is 3. That is what he is taking. So he is putting L at 3 and R also equal to L. That means R also at 3. Now what have we discussed? We are basically saying, okay, first L elements are the responsibility of left. Next n minus L elements are the responsibility of right. So basically we can say that the first time when left comes, or from the end if we are processing it, then this is the first thing that left should process. This is the first thing that right should process. So we can say for L, we first have to decrease by 1 and then process it. For R, we can directly process the R. So for L, we have to come one step back because this is where tourist is actually starting from. We can initialize in a different way, but what tourist does is he basically says that, okay, to my L, to the left of my L, I have L different elements to be taken through my left commands. So what will L do? L will say, okay, I'll go to the left and take an element. Then I'll go to the left and take another element. R will say, okay, I am at the first position of right. So this is my right and this is our left. That is how he has chosen. Based on the initialization, that part will differ. So if I again come back, if we again look at this, so R equal to L. Now we are going from the end to the beginning. These are all offline queries. All the commands are given together, so we can sort them according to our need. So we are going from the back to the front. So the last query, if that is last command is L, so we will say, okay, minus minus L. A quick C++ thing. You can actually see this has been done in probably the lowest number of lines of code. What he has done is first reduce L, then take that particular index element and immediately do a modulus of M. Multiplication modulus have the same precedence, so no issues there. If it is not equal to L, if it is R, then what will you do? First take that element, take AR, then do R++. So totally fine as per our objective. R++ will happen after taking that element. Finally, answer I equals to none. Sorry. Next, I equals to n minus 1 answer I. Okay, he's printing answer I and then uh, slash n. This is basically printing the answer. Yeah. Okay, so that's it. Now let's move to the next problem. Problem number D. Card game. This basically tells us that we have a 32 card deck. So we have 32 cards and there are 4 suits. And now one suit, similar to many of our card games, we have the trump suit. And in each round, players make moves like this. The first player plays one of his cards on the table. Second player must beat the card with one of their cards. So it's kind of a game theory question where we have to make the second player win. First player will give a card, second player must beat that card. That is the objective. Not at the end, not, I mean, he has to win majority, he has to win all the. Second player has to win at every particular step. Okay, a card can beat another card if both have the same suit and first card has a higher rank than the second. So if same suit basically means same C, D, H, S, whatever it is. So if it is 8S and 4S, it's something like 8 of spade and 4 of spade. So something like that, then the bigger number will basically defeat the smaller number. So 8S, the one who has 8S is going to win. The one who has 4S is going to lose. Additionally, a trump card can beat any non-trump card. A trump card can beat any non-trump card. So if let's say, I think an example is given. If the trump suit is C, then 3C can beat 9D, 5D, any D, or any H, or any C, something like that. No, sorry, C is the trump card, so anything different. Note that trump cards can be beaten only by trump cards of higher rank. So if there are two trump cards, if both of them play a trump card, the higher one will eat up. Now, there were n rounds played, so the discard pile now contains 2n cards. You want to reconstruct the rounds, but the cards are shuffled. Find any possible sequence of n rounds that might have been played in the game. Okay, so basically, the second player sort of assume that the second player is basically going to beat the first player at every round. Now you have to construct those n rounds. You have the 2n cards. Now shuffle them in any way, assign them in any way, and make the second player win. Don't think in terms of the first player. Make the first player give the worst possible moves and make the second player move the best possible things and make him win. Okay, so now how we will do it. This kind of a greedy approach, you can say. Now what is n? N probably is the number of moves that will happen, and there are these are the 4 suits. One thing that is not written over here but sort of implied, that is, if one of them plays C, other of them plays S or D, and none of them are trump cards, then there is no conclusion as such, and we don't have to worry about that case because we have to make the second player win. There is nothing like a draw that we have to worry about. Second player has to win, so second player has to defeat by the number or by trump, either of them. Okay, so let us take an example. Let us say this one. 3C, 9S, 4C, 6D. 3C, 9S, separately. 3C, 9S, 4C, 9D, 3S, 7S. Okay, so if I say that the first one will first play this and the second player will play this, can I say this guy will lose to the second one? So the first move will be as we wanted. Okay, who is the trump over here? Let us see. The trump is S. Trump is S. If we say, okay, let's give 3C and let us give 9C to the for the second guy, then also this will lose to this. This is also a valid move. But if I say 3C to the first one, 9D to the second one, then this will not lose. There is nothing defined for two different, two cards of the same suit, so we can't do that. So this is one particular way. Then I can say, okay, then 9D can lose to something like 3S. So 1B and 2B. 9D will be played by the first one and 3S will be played by the second one, both in the second move. And next I can say, okay, the third move, 7S can lose to 9S. Okay, so this is pretty straightforward a problem, we can say. We have to arrange in such a way that the that guy has the worst possible cards, the second guy. Not just that, it's a good idea to actually consider pairwise, because it's not a good idea to actually assign all the C's and S to the first guy, or let's say second guy, and the other things to the first guy. That will not give us a good answer. For example, if I assign all the D's and other cards to the first guy, then somewhere that will happen that we don't have the same suits on both the sides, so nobody will win. We don't want that condition. So the best possible way is, okay, for a first move, consider that, okay, if 3C is played by the first person, who will play, what will the second person play to defeat this? This can be our strategy. So what is the best way? Let's say we have the same cards, same suit. Let's say 3C, 4C, 5C, 2C. If I have something like this, what can I say? We can sort by the number actually. We can sort by the number, and then we can say keep on assigning in this way. 1, 2, then 1, 2. That is first player, second player, first player, second player. Right? Similarly, if I have two other cards over here, let's say 2S and 3S. What can I say? Okay, take this 2S and 3S later. 2S, 3S can defeat anybody. So at the end, you can reach there, you can basically say 1, 2. Before that, try with non-trump cards. These are there to eat up any other cards. If you have suddenly a D or something like that, you can use them. So in this way, you can basically say, okay, sorting can help me over here. So the first thing that definitely comes to mind from these questions is, how can I arrange the elements so that now assigning pairwise can become very easy. Choosing the first element at least becomes very intuitive. Like over here, if 9s would have been my first element, I could have said, okay, assign this to 1. That would have been a very bad choice. But if I sort them in a way that the lowest cards stay before and the trump cards stay at the very end. Why trump cards? Because trump cards are the last possible resort for the second card to win over a second player, to win over the first player. So this is something we have to save for the second player. Save for second player. And we can say the remaining cards we can actually keep on going on assigning. So from the left I can say, okay, keep all these non-trump cards, and then from the left keep on taking, keep on assigning to 1, and the next cards, the lowest, you can say assign this to 1, and then the lowest possible card to defeat this card to 2. Now let's say you had after this you basically had 6C and then 2D. What can we say? That your 6C can basically lose to this 2S and 2D to 3S. So going from the left will not make you suffer up to here if you have a good pairing, and after that you can manage. And if at all you cannot manage, then you have to return -1, I think, or impossible. Yeah. Let us see this case as well. So impossible, the fourth case, 7S, 3S. 7S, 3S is impossible. No. 1, 2, 3. Okay, okay. This is the first assignment. This is the second assignment, which is impossible. 3S, 5D, 9S, 6H. 3S, 5D, 9S, 6H. If we look at it, trump card is C. C is not there. If I arrange them, how will they look like? Arrange in any way. Take the S first maybe, so you have 3S and 9S. Or even if I don't take the S first, I can take, let's say I take the S first, and then 5D and 6H. I can take in any order. Let's say 5D and 6H. Now if I say, okay, 3S will lose to 9S, then 5D will not lose to anything. not possible. So immediately I can say this is impossible. If pairing is not possible, you can return impossible. You can try out on these test cases, you will find the same. So what can be our approach? Basically, sort them. So let us see how to solve this problem. Yeah, yeah. He took the string and then he sorted it with his custom comparator. What did he do? He actually said that he has two strings A and B. What is this returning? This will return something like a boolean thing. If the boolean thing is true, then that means A is less than B. If it returns false, if this function returns false, that means A is greater than B. And according to that, it will sort it. And just a small knowledge sharing about comparator thing. This is the condition based on which any two elements will be compared. Finally, your algorithm will do n log n operations on these n elements. So n log n times this particular, around big O n log n time, this particular snippet will run. Okay, so what are we doing? We are, first of all, what he is doing, he is basically checking, hey, is it trump? Is that trump? And then he is checking not equal, which means that either this is trump or only that is trump, not both, not neither. That is what he is doing by not equal. So each of them will return a Boolean expression. AI equal to T, BI equal to T. What is T? He has taken that trump card in the T, trump suit in T. Now he is checking, one basically means the second character in each of those things. So if you look at the test case, 6C. So here the second character is C. He has basically taken that over here. So if only one of them is a trump card, then what is he saying? That okay, if second one is a trump card, then return true. If second one is a trump card, then what did I say? If it returns true, then that basically means A is less than B. A should be placed before B. So yes, the condition is correct. If the second one is a trump card, not the first one, then second one should be at the last, first one should be at the first. That is the condition is applying. Return true. So BI, if the second one is a trump card, then return true. That means keep A at the beginning. If second one is not a trump card, that means first one is a trump card, and that means keep the first one later, which means keep the second one before. So it will return false. So that is a quick thing that he did for balancing, for basically saying push the trump cards at the back. This is exactly the same as we discussed over here, that pushing the trump card at the back actually gives us a lot many advantages. Next, if both are trump cards or both are non-trump cards, what is he doing? Sorting by the number. AI not equal to BI. If the number is different, I'm sorry. So this is the test suit, right? This is the test suit. CD, this is the test suit. So this guy is actually checking that if the test suit is different, then solved by the test suit. What does this mean? This basically means that group by the test suits. Group by the test suits. This actually again is similar to what we discussed over here. First some C, then some D, whatever. This ordering doesn't matter, but grouping by the test suits is actually a good idea. And then finally, if basically the suits are the same, then this one becomes compulsory. A0 is less than B0. Definitely a very good approach. Now what has he done over here? He is, this is a kind of Boolean array which will tell which elements we have taken and which ones we have not taken. And then we are moving from the beginning to the end of the array. And we are saying that, okay, for if I is remaining, take I, give I to the first player. This is sort of implied. Give I to the first player. and now move from I plus 1 till the last element. So this is a kind of brute force thing. From this place it appears that okay, outer loop goes n times, inner loop goes n times, so it is n squared times. Will it allow? We can see that yeah, n goes to 16, so even if it is n squared, it will allow. Whether it is n squared or not, we can see that. So what happens? It is checking that if j is alive, that is j has not been taken yet, and sji is equal to trump card. That means if we have reached a trump card, that means definitely no other non-trump card has been able to help us. So take the trump card. Either it is a trump card or it is of the same suit as the ith element. So for the ith element, I'm basically finding the first element from the left, which can be my jth element, which has to be non-taken till now, and which is either a trump card or it is of the same suit as own self. And then what can we say? We can basically say add this, take this as a pair, mark both of them and break. Break will basically break off from this innermost loop, so no problem. It will iterate for the outermost loop as we want. Then coming over here, so we can say this is pretty optimized. Will it work if I do this as A0, first the A0 condition, then the A1 condition? Yeah, then also it will work because we have grouped the trump card separately, and over here we are basically sorting by numbers. Because of this checking, we really don't have to be, or we have a lot of options over here. But again, which is the best option? This is the best option because this helps in grouping all the diamond cards, all the hearts cards, all the spades, all the clubs, and so on in that way. The trump card stays at the end. So something like that. So definitely this is, again, in my opinion, in my understanding, I can't give an opinion on these people, but in my understanding, definitely this is the best way in which probably it can be coded. Yeah. What is the time complexity? Is it really n square? Uh, Actually, yes, because for some elements, though we are breaking, though in the grouping, some of them will not require J to proceed till the end, but still overall, many elements might require us to reach till the trump card. In fact, it is possible that for all the elements, we have to reach to the trump card. But this is definitely still the most optimized thing that probably should be attempted in this problem. Uh, What if n was large and we could not take it to n square? There can be a discussion. I think that is also possible if we use a two pointers thing. If we have a pointer at a trump card to say that as long as this suit is going on, there is no other option. So proceed according to the trump cards, take along the trump cards. That is possible. But definitely, tourist also didn't think at all in that direction because this totally doesn't require us to think so. So yeah, this problem was solved in I'm sorry, 5 minutes. Definitely tourists would have done faster than that, but we are not going into that. Yeah. Proceeding to the next problem. Final countdown. So what are we doing here? We are basically saying that there are n mechanical indicators, each showing one decimal digit. You notice that when the countdown changes its state from x to x minus 1, it doesn't happen in one move. Instead, each change of a single digit takes 1 second. So 42 changing to 41 happens in 1 second because only one digit is changed from 2 to 1. But in case of 2300, when it changes to 2299, you can see 3 digits are changing. So it will take 3 seconds. So now an n digit string is given to us. String basically it's a number, n digit number, and we have to say in how much time it reaches 0. So let us see, let us say 42. So 42, we can say it comes to 41 in just one step, then it comes to 40 in one step, then if it comes to 39, we need to change 2 digits, so it will need 2 steps, 2 seconds. Then to 38 again 1 second, and so on. Up to 30, 1 second every step. Then to 29, so from 30 to 29 it will be 2 seconds. Now let us see, for these kind of problems, the first thing that I want to actually do is try to see the pattern. So for single digit numbers, for 1, you just need a single second to reach 0. So for 1, the answer would be 0. If we have a simple example like this, we can show like this 5. So for 5, we can see that the answer is 5. Yeah. So we can say, yeah, for 2 also, 2 times, every time a single digit is affected. So 1 second for every subtraction. So it will take 2 seconds in total. 2 to 1 and 1 to 0. Right? 2 to 1 and 1 to 0. Now, fine. What about 10? Up to 9, this is sorted. For 9 also, it will take 9 seconds. What will 10 take? For 10, we can say, hey, first time to reach 9, it will take 2 steps. And then from 9 onwards, 9 to 0, it will take exactly 9 steps. We know that. So it is 2 plus 9 equal to 11. Great. No pattern yet, but let us solve a few of them. What about 11? 11 is simple. So for 11, it is basically 10, and after that 1. So from 11 to 10, it is only 1. So it is nothing but 11 plus 1 equal to 12. What about 20? So what the idea that I get from here is, from 11, I can basically say, take care of this 1 first, so that you bring this to 10. Take care of this last one. You need just 1 for this. And then for the remaining 10, you need this 11. So we can divide it into those 2 parts. That is the first thing I'll say. Next, what about this 20? I can say for 20, hey, to take this 20 to 10. To take this 20 to 10, I can say it's quite similar to taking 10 to 0. Why? Because the first time 2 digits change. After that, only 1 digit change. This is, all of them will be 1, and this will become 8, 7, 6. So 20 to 10 and 10 to 0 is the same thing, which means 11 into 2 is definitely going to work here. 22. 30 also. 30 to 20, same thing. So for 30, I can say this is nothing but, again, plus 11, so 33. What about 100? For 100, I can say, okay, 100 to 99 will take 3 seconds. 100 to 99. Then for 99, how much will this take? We have discussed that to take from 99 to 90, it's simply 9 different steps. And once it comes to 90, we know it is just 9 into the answer for 10, because 90 to 80, 80 to 70 are all the same thing. So 9 into 11 is basically 99. And what does this give us? 99 plus 9, 108 plus 3, 111. Great. Can you see the pattern? For 1 it is 1, for 10 it is 11, for 100 it is 111. What next? If I say 200. For 200, again from 200 to 100 it is 111, and for 100 to 0 it is again 111. So we can say 2 into 111, which is 222. Next, what about 1000? Same thing, 1000 to 999, 4 steps, 1000 to 999, 999 to 990. So 1000 to 999, 4 steps. From here to 990 is basically 9 steps. From here to 900, for 90 we know it is 99 steps, and from 900 to 0 we know it is 999 steps. So can I write in this way? 999. Can you see 9 plus 99, then 9 plus 99 plus 999? Let us see what the answer is. So if I distribute 1 into each of them, so I get 1111, sorry, 1110 plus 1, so it will be 1111. So what do I notice over here? for every one digit number or for any one digit value, I basically have 1. For 10, I have 11. For 100, I have 111. For 1000, I have 1111. If I basically try to calculate one of my answer in this way, let's say 1, 2, 3, 4, 5, which is given in the test case. Let us see. 1, 2, 3, 4, 5. What did we discuss? 5 into 1, 4 into 11, 3 into 111, 2 into 1111, and 1 into 11111. So what do we get? 11111, 2222, 333, 44, and 5. 15, 4, sorry, 10, 11, 7, 3, 1. 13715. That is the answer, 13715. So our computation is correct. This is my strategy of always finding it out. I first find out the pattern, then I calculate for one of the answers and I see if my answer is correct or not. In some cases, it is not possible to calculate it by hand, and then I have to quickly implement and see whether the answer is correct or not. Sometimes I end up, sometimes I implement a brute force and see whether my answer is coming out to be correct or not. Great. Now, how to solve it? Basically, if I'm able to find out all these things, then I'm able to solve. Do I have to return? Okay, first of all, how big can this go? The number of digits goes up to 10 to the power 5, 4 into 10 to the power 5. It's not the total number, it's not the string, it is the number of digits. 4 into 10 to the power 5. 4 into 10 to the power 5. So basically, I am saying that I may have to do 10 to the power 4 into 10 to the power 5. Is this possible? No. I can't imagine to form a number like this and then multiply that with any number. This is ridiculous. So this contest is actually very good in dealing with large numbers and finding out ways on how you can avoid dealing with those numbers as a whole. Now, here one strategy is to go according to mathematics fundamentals, that okay, I have this, let's say my number is given in an array A. I have these as my digits, A1, A2, A3, A4. Let's say this is my 5-digit number, my n is equal to 5. Then I have to multiply this by 11111, this by 111, and so on. If I basically have to do this 1, 1, 1, and so on, can I say I can group in some way? Can I say that for the leftmost one, 10 to the power 4, only A0 is there, only A0 is responsible, A0 into 10 to the power 4 plus, let me complete this so that it makes sense. 111 plus A3 into 11 plus A4 into 1. If I think about the next one, 10 to the power 3, what can I say? My 10 to the power 3 occurs over here as well as over here. So can I say this is A1 for my 10 to the power 3, I have the share of both A0 and A1. A0 plus A1 multiplied by 10 power 3 plus I have A0, A1, A2. That summation with 10 to the power 2 plus A0, A1, A2, A3 into 10 to the power 1 plus everything A0 plus A1 plus A2 plus A3 plus A4 into 10 to the power 0. Yeah, this makes sense. Now, how does this help me? Now I know that, okay, Can you visualize this, that I'm basically adding these numbers in the first place, then I'm adding these numbers in the second place from the right, then I'm adding these numbers in the third place from the right, these numbers from the fourth place from the right, and this number in the fifth place. And basically, if anything carries over from the rightmost point, I can take that to my leftmost point. So if I take this example, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What are my summations? My summations are 1, 3, 6. Summations, that is these summations. These summations. The red rectangle summations. 10, 15. So can I say, okay, basically, I want to add them. In the units place, I want 15, I want 10, I want 6, I want 3, I want 1. But in one place, I can't have 15. So basically, I can take 5 on adding. I can take the 5. Basically, this is, I have to take 15. So I can take 5 and then I can send that as the carry. Right? We can send that as a carry. And then 1 plus 10, 11. I can keep 1 and send that as a carry. 1 plus 6 is 7. Then 3, then 1. Can you see I can solve it in the form of an array? I just read this. I have an array over here. I found this prefix sum, or whatever you say, suffix sum over here. And then I just distribute. I basically say, hey, shift to the left to all your carries. Right? I can do this. Okay. So let us basically see. 13715, we got the correct answer. Now let's see how Tourist has solved it. This actually is a good problem for even Div 2 participants to solve during a live contest. Now let's actually see. Tourist has done nothing different. In a very short code, once again, he has taken the summation up to this point. Now what has he done? He has first of all reversed it. Why has he reversed it? Again, it's not possible to infer from here, but probably to get the feeling of a prefix sum. Sorry, this was a prefix sum in what we used. So what could have been the reason for reversing it over here? Again, let us proceed and let's see if we can make out some meaning. He goes from the end to the beginning, then he adds, he keeps on adding that same value. Basically it's as string, it's located as string, and now he is taking as integer. That is the reason behind this minus, nothing else. And then he is taking that into AI. Then he is proceeding from the left to the right because of the reversing. So okay, now the reason is clear. Basically at the 0th position, when we say this, what we understand by the units place is basically this position. This is our units place, or this is our units place. This is our units place. This is our tens place. So Tourist might have found it logical to actually bring this to 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So he might have found it logical to bring this to a scale of 0, 1, 2, 3, 4. So he just reversed it so that now from 0 the computation always starts. He gets the feeling of going from units place to the tens and hundreds place and so on. Again, it can be totally different. I'm just trying to gauge what this great programmer has done. It's not possible to totally infer from this much, but yeah. So now we are moving from 0 to n. That is the idea. And then what are we doing? We are basically saying, okay, plus carry, whatever you have got, whatever carry you have got from before this step, add to the carry. This is the sum. And then modulus 10, whatever you get modulus 10, that is your current value. And whatever is, on dividing by 10, whatever you get, that is the carry. The order of the last two lines can be anything. First sum, then carry, or first sum, first carry, then sum, whatever. And at the end, what have we done? This is a very important step. That if any carry is left over, so it has surpassed the value of n, then we will keep on pushing back the modulus carry modulus 10. And this is also an interesting part. Over here, if we have to push back, in our solution, if we have to push back, we have to push back in the left. But in a vector, pushing back at the left actually means slightly difficult. So what he has done is, he has started from this position so that pushing back in a vector will actually need us to go in the right direction. Push back means it will push at 5 and then at position 6 and position 7 and so on. That is correct. He doesn't need to reverse it or do such steps. But over here, if we say, okay, we have this and now we will push at the front, we will insert at the front, then keep in mind that vector dot push back or basically insert, if there is an insert function or whatever, if I want to insert at 0 something, whatever I want to insert, this is a difficult operation, this is a big O operation. You should avoid this. So this is again an interesting thing that we get from here. It appeared that probably this reversal was not that important, but over here he is optimizing that. And the fact that he codes this solution E in 2 minutes, I don't know if there was some time shared over here to that one, but basically codes this in quite short time. And within that, he has actually figured out that over here this pushback might cause a bit of trouble, and hence reversing this will actually give us some benefit is actually a great thing. Again, it can be totally different also, that maybe it could happen that without reversing he would have done up to here and then he would reverse it and then he would push back. That also could have been done. Again, not going too much there, but definitely it makes a lot of sense. Over here just a pushback actually helped in taking care of the remaining carry. This definitely makes a good deal of sense over here. This reversal makes a good deal of sense. Now at the end, what are we doing? We are basically saying if a dot size greater than 1, a dot back is equal to 0. This basically says don't take leading zeros. So for that 0005, we are basically printing only 5. So at the back, you can keep on removing. A dot size greater than 1 and a dot back equal to 0. A dot back, yeah, again back means from the end. So the leftmost position according to our numerical system. So again, reversing helps both of these in the same way. Finally, we are printing from the end. So how is it arranged? It is arranged according to the 0, 1, 2, 3, 4 in this position. So we have to print from the end, from the 4, then 3, then 2, then 1, then 0, so that it prints from left to right. So that is the way it is printing. The entire thing has been managed through one array. He did not take it out of the array. He did not form any big integer kind of a thing, no long integer, just managed in this way. So yeah, this is definitely an impressive piece of code. So in the next video, I'll be sharing how he has solved the next two problems, F and G, which are definitely based on much bigger data structures, much more interesting facets are there. We will discuss that slightly, and yeah, and probably we'll get some rich insights over there as well. Let me know how you felt about the session. Let me know if you want me to do similar sessions with other solutions or on other contests. And let me know if you found this session interesting. Take care, keep coding.